Hello everyone, in today's video we are discussing about DSA tree traversal of binary tree part. Okay, in this video we are discussing traversal of binary tree. How we traverse a binary tree, that's very important for your interview, for your examination, everything. Okay, so without further delay, let's get started. Traversal of binary tree. There are three type of traversal. First one, pre-order traversal. Second one, in-order traversal. Third one, post-order traversal. In pre-order traversal, we are written. We have three steps. One step is visit, then left, then right. Left child, right child. Okay. Step one is visit the node. How you traverse a binary tree? At first, if you need pre-order traversal, then you have to visit the node. Step 1. Step 2. Traverse the left subtree according to the pre-order. After that, step 3. Traverse the right subtree according to the pre-order. When I take some example, at this time you will understand better. But in this time only you have to know the rules. And in order there is LVR short tricks, VLR, and in post order LRV. L means left, R means right child, L means left child, V means visit. Post order traversal. Step 1, traverse the left subtree according to the post order. Step 2, traverse the right subtree according to the post order. Step 3 is visit the node. In order, traverse the left subtree according to the in order, visit the node. Step 2. Then step 3 is traverse the right subtree according to the in order. So there is an example, very simple example. By this example you can understand every traversal very easily. At first we are discussing about the post order traversal. Okay. No, at first we are discussing about the pre-order traversal, that is VLR, visit left and right. We have to start from the root node, that's A. At first we are starting pre-order, then we have to visit the node, visit the root node. And when we are visit a node, at this time we are written in the pre-order output. Okay, so at first we visit A, then write A, we are written pre-order. Okay, pre-order, then write A. After that, in pre-order we know visit left, right. So after that we have to go in the right side mean B. So in B, at first we have to visit the V, because we know VLR, at first visit, then left, then right. So in B, visit is completed, then we have to go in the left side, left subtree there was D. So at first we have to visit the D, then after that right subtree of B means E, so visit the E. Okay, after that left subtree of E there is nothing, so we have to go in the right subtree of E. Okay, then F will be there, then F is in the visited state, F. Okay, after that F left subtree Z is visited, and after that H is visited. And you know, at this time the root node A, left subtree, all things are in the visited state, that's why we go in the right subtree. So C, you can see this is the answer, A, V, D, E, F, G, H, C. Like that you have to traverse pre-order. After that in order same things, but in order we know L, V, R. In pre-order, we visit left, right. In post-order, left, right, then visit. So at this time, in order example. Example of this, we have to make this in order. In order, if we need to make this in order, then we have to do we have to do from root node, that's A. At first we have to do left, then visit, then right. That's already we are know, left, visit, right. So at first we have to go root node left. Root node left is B, but B have a left subtree. That's why we have to go in the D. So D have not left subtree. That's why we have to visit in the D. So we are written a D in order traversal. And after that, right of B. Right of B means E. Okay. Then E have not any left subtree. That's why E in the visited state. Sorry. In order, left, visit, right is left, visit, right is happen. In order, left, visit, right is happen. Okay. So by this example, we also understand in order. So at first we have to start from the root node A. So left, at first we have to go root node A, left subtree. Left subtree means B, and in the B there was a left subtree, that's called D. So in the D there is no left subtree. That's why no left subtree means left is nothing, and after that visit, we have to visit the D. So we have to write D in the in order traversal. And after that we have to, we know at first left, then visit, then right. So in the B, left is completed. So at this time B is in the visitor state. After that that's go in the right side. Right side means E. Then E have not any left subtree. That's why E is in the visitor state. After that, going to the right subtree of E, that's called F. F have a visited F has a left subtree. That's why we write Z. Then after that visited F, Z, F. Then we have to write H, because H have not any left subtree or right subtree. That's why this is visited. So the entire left subtree of root node A is completed. That's why at this time A is in the visitor state. After that we have to visit the C. So this is the answer of this example in order traversals, and we already know the pre-order traversal. So at this time we are calculating the post order traversal LRV by using LRV rules from this same example. At first we have to go in the left, then right, then visit. So we are starting from the root node A. A is V subtree. Then we have a D subtree. D have not any subtree. You know, D have not any subtree. Left, not right. That's why D in the visitor state. Okay. That's why D in the visitor state. After that B have completed left subtree but not right subtree. That's why B is not in the visitor state. That's why you have to go in the E. E have not left subtree but E have right subtree. That's why you have to go in the right subtree. F have a Z, but Z have not F have a Z left subtree, but Z have not any right subtree or left subtree. That's why Z in the visited state. Okay, that's why Z in the visited state. And after that H in the right subtree of F. That's why H in the visited state. After that F is in the visited state. And after that E in the visited state. After that B in the visited state. After that we know the root node A left all element is completed in the visitor state. So you have to go in the right side, then visit in the root node. Right side means B, after that C, after that A. You can see this is the answer, D, G, H, F, E, B, C, A. This is very simple. By this process you can construct any binary tree using pre-order, in order, and using post order and in order. You can make any binary tree. So there is an example, construct a binary tree using this pre-order and in order. You know, in in order you have to see in order traversals to make any binary tree. In order is compulsory. After that you can give post order or pre order, but in order is mandatory. Okay. So this is the example, pre order traversal 110, 50, 40, 80, 70, 200, 150, 160, like that in order. Okay. So in pre order we have to go from left to right. Okay. So first element in the pre order, that is 110. This is in the root node. The first element in the root node, you can see in the pre order traversal A, first element in the root node. Okay, that's why you have to go left to right and write all element. Okay, you have to go left to right. So 110 in the root node. You have to see in the in order traversal 110. Where is 110? In the middle of this. So the remaining all things in the left side, that is the left subtree of the 110 root node, and remaining all element of the right side, that is the 110 root node right subtree. So you have to write like that. This is step 1. 110 is in the root side, and after that every element in the left side is written here like that, and every element in the right side of 110 is written here like that. There after that step 2, but 40, 50, 70, 80 you have to go in the pre-order. There is a 50 after 110. So 50 is in the root node of this left subtree. Okay, then 150, 160, 200 you have to go this side, and you can easily saw 200 is in the first. So that's why 200 is in their root node, and 50 is in the root node. And after saying the 50 is root node, then you have to find in the in order 50. Where is 50? 50 is there, then 40 is in the right side, and 70, 80 is in the left side. Sorry, 40 is in the left side, 40, and 70, 80 in the right side. Okay, very simple. Then you have to go also 200. Where is 200? 200 right subtree 150, 160. That's why you write like that. But sorry, left subtree 150, 160, but right subtree there was nothing. This is step 2. There was 70, 80 and 150, 60. You have to traverse, construct a binary tree from this also. So 70, 80 you can find from the pre-order. 70, 80 is in the first, so 80 is in the root node. 80 is in the root node, and you can find in the in order. What is 80? 80 left side have 70. That's why you written left side of 80, 70, and after that 150, 160 you can see in the pre-order traversal 150, 160. 150 is in the first position, that's why 150 is in the root node, and after that 160 is in the right side, of 150 in order traversal. That's why 160 is in the right subtree. Very simple. And after that you can make also a post order in order you can make also a binary tree from post order and in order. Okay, post order FA EKC DHGB and in order. You can make this also like that. At first you have to know in post order. Sorry, this is not post order, this is pre order. At first you have to in pre order, you know, first element is in the root node, so f is in the root node. So in if you have to find the f in the in order traversal, then you can see the f is in the root node, and remaining all element in the left side is in the left subtree of f, and remaining all element of the right side of f is right subtree of the f in our binary tree. This is step 1, and after that you have to make the ESCK from this. A is in the root node, so that's why you have to write A, and after that k is here, that's why k is in the root node, and after that you can see in HDBZ there is d is in the first position, that's why d is in the root node, and h is in the right subtree, h is in the left subtree, and g is in the right subtree. Like that you can make. This is also like a previous example. This is using post pre order and in order, and at this time we are discussing about the post order and in order. Using post order and in order you can make a traversal. You know, in post order we have to go right to left. We have to take a element from right to left. We know in p order we are taking element from left to right. So 8, at first 8 is here, so that's why 8 is in the root node, and similarly we can find 8 in order, and 11 13 6 is in the right side, and 20 19 24 is in the left side, and after that 8 is in the root side, and 20 19 24 20 is in the first position, that's why 20 is 20, sorry, you have to go right to left. Okay, so at first 13 after 8, so 13 is in the root node, then you have to find 13 right side is 6, left side is 11, so right side is 6 you written, left side is 11, that is in the binary tree. Okay, so after that you have to find 19. Where is 19? 19 24 20, so 19 is in the root node, and 24 is in the right side of 19, and 20 is in the left side of 19. It's very easy. Similarly you have to only change the collecting point, viewing point. In post order you have to go right to left, and in pre order you have to go left to right. That's the change, but everything is same. At this time we are discussing about binary search tree, that is called BST. A binary tree is called binary search tree if the value of the left child is less than of its parents, and the value of right child are greater than of its parents. Then we can say this is the binary search tree or BST. What is written in this sentence? If you make a binary tree like that, you have to know in binary search tree, if the parent node is there are 3, then you have to write in the left subtree smaller number then the parent. You have to write like 2, and in the right subtree you have to write greater than the parent number. You can write 5. This is called a binary search tree or BS tree. You have to know in the parent node or in the root node, the element left subtree is lower than the root node element and right subtree is greater than of the root node or parent node, parent value. Then there is an example of construct a binary search tree for the given value 50, 30, 60, 38, 35, 55, 22, 59, 94, 13, 98 like that, and answer a 50 insert 30. At first we have to write like that. At first we have to do from left to right, so you have to go left to right. At first we insert 50, then insert 30. If you insert 30, then 30 is in the left subtree of 50 because 50 is here our parent node or root node, and after that completed for 50 30, then we have to insert 60. Then if you insert 60, then 60 is in the right node because 60 is greater than the 50. After that we have to write 30, we have to insert 30, then 30 is in the left right subtree of 38 is in the right subtree of 30 because 38 is greater than 30, that is why. After that 35 is inserted. 35 is in the left subtree of 38. Okay. After that 55 inserted. 55 inserted. When 55 is inserted, then you can say the 55 is in the left subtree of 60, and after that 22 is inserted. The 22 is inserted, then the left subtree of 30 is in the 22. Okay. Then after that you have to you have to insert 59, then 59 is in the right subtree of 55. If you write in your copy, then you can understand it very easily. Insert 94, 94 is in the right subtree of 60 because 94 is greater than 60, that is why. After that insert 13, 13 is in the left subtree of 22 because 13 is lower than 22. After that insert our final value 98. 98 is in the that is 94. Okay, 94 is in the right subtree of 94. It is written here 94 because 90 is greater. So this is the final binary search tree. You can make this easily. There is nothing logical thing. This is very easy. You have to go left to right, then you have to visit only one by one inserting. You can do this, and if the element is greater than the parent node, then you have to write in the right side. If the element is greater than the root node, then you have to write in the right side. If you see the element is inserting you that's lower than the parent node, that's you have to write in the left side. That's the things. This is very easy. At this time we are discussing about heap tree. What is heap tree? There is a two type of heap tree: maximum heap tree, minimum heap tree. Heap tree means maximum heap tree means in parent node there is a maximum value and every child have a lower value if you compare with the parent value. In minimum heap tree there is a parent node have a lower value and every element, every child and every subtree have a maximum value, greater value from the parent node. That is called minimum 50. You have to remember in our parent node there is a maximum number or greater number, then that is called maximum 50. If in our parent number there is a minimum number, then that tree is called minimum 50. Okay. There is some example of construct a maximum 50 for the value 100, 200, 30, 50, 40, 25, 250, 175 like that. At first we have to go like that previously construct a binary search tree, you have to go left right every time. Okay. At first you have to write 100, then insert 200, insert 200. If you insert 200, then 100 is in the root node and 200 is in the right node. That is not maximum 50, that is minimum 50, because root node is dual value. If we compare in the with if we compare with the child value, so we have to heapify. This is called heapify. We have to write like that heapify, then the parent node will be changed to the getter value. So 200 is in the root node and 100 is in the child left subtree of 200. After that we have to insert 30, 50, 40. We can insert one of we can insert more element from this given sequence. Okay. So insert, if we insert 30, 50, 40, then we can see 200 is in our root node and 100, 50, 40, 30 is in our parent node, is in our child node. Sorry. So 50 is in the right subtree of 100, 50 is in the left subtree of 100, and 40 is in the right subtree of 100, and 30 is in the left subtree of 200, because 30 is lower than the 200. Okay. You know what, in this example, in this heapify process, you have to write like that. At first you have to write first element 100, then you have to write the left subtree. There is any element written, but you have to write in the left subtree, that is 200, and after that you have to heapify. Then after heapify you have to write in the right subtree, that is 30 is in the first position, and after that left subtree of 100, after that right subtree of 100, and after that you have to write left subtree of 30, right subtree of 30. You have to write like that. What element is here written, you have not see, you don't see. Okay, you don't need to see. Okay, like that you can write written. After that you can insert 500. So 500 is in the right subtree, that's I already say, but 500 is greater than the parent value, that's why you have to heapify. If you heapify, then 500 is in the root node and 200 is in the 30 position and 30 is in the 500 positions. Okay. So after that 250 is in the inserting position, then 250 is in the right subtree of 200, but you have to make 250 is in the root node of 200, is in the 200 position, and 200 is in the 250 position. That's why you have to heapify. After heapify, you have to insert 175. In 175 is in the right subtree, left subtree of 50. That's why you have to do heapify, because 175 is greater than 50. That's why you have to make 175 is in the right subtree of 500, and after that 175 left subtree of 500 is 175, and after that right subtree of 175 is 40, and left subtree of 175 100 and 100 left subtree is 50. This is very easy. This is final maximum heap tree. You can also make a minimum heap tree by this process. You can see 10, 50, 17, 13, 18, 20, 25, 28, 16. At first you have to go left to right, that is why you written 10. After that insert 50 and 7, 15 and 17, okay. 10, then 15 and 17, this is minimum heap tree, okay. Insert 13, if you insert 13 is in the left subtree of 15, then you have to heapify, then 13 is in the 15 position and 15 is in the 13 position, and insert 18, 20, 25. If you insert 18, 20, 25, you can write that. You can write like that 18, 20, 25, okay. And after that insert 28, 26, 28, 16, then the minimum heap tree is like that. This is very important and very easy. Minimum heap tree and maximum heap tree. You have to only do a example in your copy. After that you can understand very easily. So there is an advantage of a binary tree, binary search tree. What is the advantage? Searching an element in time efficient, okay. If any binary search tree traversed using in order, then the sequence will be sorted. This is sorting called tree sort. Step 1, construct a binary search tree. After that, traverse the tree using in order traversal. In binary search tree, if you do in order traversal, then the every element is in the sorted order. Example, sorting the all value using DSA and in order traversals. This is the example 40, 20, 60, 10, 30, 50, 70, 30, 15, 35. If you make a binary search tree this from this given value, then the in order traversal is 10, 15, 20, 30, 35, 40, 50, 60, 70. It is the sorting order. So that's it for today. I think you understand everything. That's today's learning process, to today's learning things, today's learning topics. So after our future video, in our future video we are discussing MOA search tree, that's called multi-OA search tree, and V tree, and many FBL tree and high valence tree, and many things, okay. So that's it for today. You have to practice this binary search tree example, constructing and heap tree, minimum heap tree, maximum heap tree, and traversal of a binary tree. That's a pre-order traversal, in-order traversal, and post-order traversal. That's it for today. If you like the video, then you can subscribe our channels and also join our WhatsApp group. Thank you for today. Goodbye.